I got a question on PCV valve systems yesterday that wanted me to give you some more content. PCV systems have to control crankcase vapors, right? We do that via vacuum from the intake manifold, but do you recall how much intake manifold vacuum we could possibly have, right? It could be pretty high. So 17 inches of vacuum would definitely be way too much vacuum on the system. We're going to draw air in past our seals essentially and create oil leaks when the system is not working. So we need to regulate that. So this truck is a V8. That's why I chose to do this video or use it for this video today. And we're going to put a vacuum gauge on the PCV system so that way I can show you how low that vacuum actually is coming in. Now with a vehicle such as this that is a V8, right, we're going to draw fresh air in from the passenger side valve cover right from our clean air after our filter on our intake tubing, right? So that's not a feed to the intake, that's actually drawing from the intake, and we'll prove that here with our gauge. And then we're going to suck that air essentially through the cylinder head, through the block, and then back up to the other side of the valve cover where we will exit via our PCV valve. So this has a valve in it that you can sit there and jingle. Maybe I should do that. Right, this valve will rattle. That valve is going to allow us two great things, right? It can regulate the vacuum that's going to go into the PCV valve system or into the crankcase, right? And also that valve can restrict any intake backfires that may happen. So if we have a backfire, we can slam that valve shut. That way we're not pressurizing our crankcase system with a potential backfire and blowing the seals right out of our block or potentially having an explosion from those gases that are in our crankcase as well. Let's take a look.
So you can see I pulled the hose off from our fresh air intake that feeds the passenger side valve cover, installing the vacuum gauge, and we go down to about 2 inches of mercury there. So not a lot of vacuum in the system on this side. All right, let's disconnect the PCV valve. Notice we go to 0 PSI at this point now, and then pulling the PCV valve from the system will actually create a large enough vacuum leak to stall the engine.
Now let's take a dive down another PCV system, shall we? So we looked at our fixed orifice systems on some of the vehicles that you had that were built into the valve cover. On this system here, we're kind of dealing with the same type of thing, but we actually have a valve built into our intake manifold. Right here's where our PCV hose comes in. I'll bring you guys in close here right now. And then we are going to go down next to the runners on this manifold to go into the cylinder head. So if we look at the flow on this system, right here on the cylinder head is the port which we are going to flow our crankcase gases. Now at this point you're probably wondering, where do the PCV gases go? How do they get transported through this hole in the cylinder head? We are going to take the smoke machine here and actually go into this port. And now what I'm going to do is remove the valve cover off of this engine so we can trace that location. Now pretty easy to see since we've got the smoke there, and I'll zoom you in close on this so that way you've got the best available shot on what we have going on here. But right there, coming out of a passageway in the cylinder head, is our smoke from that PCV system. So we have to circulate air in order for this system to function properly, right? Obviously, we're not circulating any air here yet. We've got no fresh air intake coming in for us. So how do we make that happen? If we look on the other side of this valve cover, it has a complementary port right here, right? So that port in the valve cover would flow through the head. So what if we just put smoke in that port of the valve cover? where does that go? So if we look, we're feeding over to the other side over here. So that does allow us to feed different passageways in this cylinder head. So I'm going to go over here, feed this passageway in this cylinder head, and find out where our smoke goes. So while we're filling our crankcase or our PCV system full of smoke, I think it'd be a great idea to see what we got going on down here by our oil drain plug. I'm curious to see what we're going to have there once the oil's done draining. Now that we've got the oil pan full of smoke, you can see where smoke's starting to rise out of the top of our cylinder head, right there next to our cam phasers, all the way across this front camshaft that's closest to us right now. This is actually on the intake side. And as we scroll across, you can also see the smoke is starting to bellow out of the area of our exhaust camshaft as well. So simple kind of visual way to understand what's happening with the PCV system there. I'm going to go ahead and put a little air in here. And you can really watch that force the smoke out the top of the cylinder head. Our valve cover has to flow fresh air somehow. We've got to get air into the system. And so if we look on our valve cover, what we have built into it, another common failure point actually is this valve. So this valve right here will operate for us to allow us to draw in some of that fresh air, but we're not supposed to be able to lose air, right? We don't want to pressurize air out of there. Now, if you can see our port down there at the end, you can see it's just kind of faintly coming out. That was one of our ports on the back side of that cylinder head. So just another PCV system. Obviously, the newer some of our vehicles get, the more advanced these systems are. Reading description and operation of how it operates is going to be key to proper diagnostics.
Well, all right. I hope this video shines some new light on PCV systems for you and answered any questions that you may have had. I look forward to seeing you in the next video.